So 7.2 is on the unit circle and trig functions. We've talked a lot about the trig functions and unit circles over the last couple of years, but I want to review the big ideas. We're going to flip back and forth here between the presenter and between Desmos.com, so if you want to interact with Desmos.com, I will share the graphs that I have by email for anybody that's interested, and then you can kind of tinker with the transformations also. So 7.2 is on the unit circle and trig functions. A wrapping function is a function that wraps, right? It goes around and around and around and around. And when you graph these, where the input is the degree, meaning the turn, and the output is the location, either vertically or horizontally, kind of depending on whether you're talking about sine, cosine, you're going to get that as some kind of periodic function. Up, down, up, down. Those up, downs represent trips around the function, right? Trips around the unit circle become trips up and down. There's one right there. That's one trip around the circle, if you were talking about sine. Okay? There's different features to these kinds of graphs. One of the features of this graph is how tall our graph is, what is our range. Okay? And on the parent function for sine, cosine, the range is always going to be -1 to +1. And the domain, because we can go infinitely to the left and infinitely to the right, is all real numbers. This is for both sine and cosine. Periodic functions. It has a period where one can start and end back on the same graph. So this is just a repeating graph over and over and over and over. There are 6 trig functions. There's sine, there's cosine, and there's tangent. And they each have a reciprocal, okay? Not the inverse function, they're not the same thing. The reciprocal of sine x is 1 over sine x, and that's called cosecant. The reciprocal function of cosine of x is called secant x, and the reciprocal function of tan x is called cotangent x. So if you notice, every single pairing has a sine and a co-something, right? This one has a secant and a cosine, right? So each one has a co and one of the terms without the co, meaning like a corresponding or they go together pairs, and then tan and cotangent. Okay. You could also write 1 over sine x as 1 over opposite over hypotenuse, which would translate to be hypotenuse over opposite. So there's that relationship there also. So tangent O over A, cotangent adjacent over opposite. Reviewing what the unit circle looks like, I have a value on the unit circle, and that point can be represented by the length of x and the length of y. Given that this radius is 1 and that this angle here is theta, then the adjacent over the hypotenuse of 1 will be, the cosine of theta will be x over 1. So you could say that the cosine of theta is equivalent to x. You can rewrite the same thing. The sine of theta is going to be y over 1. So you could simplify this and say that the sine of theta will always be y. That's the unit circle. So every point around the unit circle is representative of some point xy, and each one of those points is representative of cosine of theta times sine, and sine of theta, not times, just sine. There's some other relationships to look at here. If I take the definition of tangent, which is adjacent over opposite, opposite over adjacent, I'm looking at y over x, which can help to give us our definition sine of theta over cosine of theta is equivalent to tangent of theta. Okay. Our other three definitions here are just going to be our reciprocal functions, that 1 over y, 1 over x, and x over y. So we can use the unit circle to easily find our other terms, but it really specifically highlights the x and the y, the cosine and the sine functions. So there's that verification, that tangent of theta equals sine of theta over cosine of theta. You can also see that O over H over O over A over H can simplify to O over A, which would be what we expected for this kind of function. Remember the function sine, the function cosine, and all of the other trig functions is a function where the input is some measure of angle or turn on the unit circle, and the output is the ratio associated with that number. So if I'm looking at sine of 30 degrees, I will always know that this side will be 1 to 2. Okay. Will always be 1 to 1/2. Whereas the inverse here of something, the input is the ratio and the output is the angle measure. So that's important to differentiate between sine function, cosine function, all these trig functions, and their inverse. You might notice here that this is called arc sine. That's just another terminology or notation for the inverse sine function, also called arc sine. You might see that noted some ways on some tests or things like that. So remember, these two things are the same thing. Make sure you have your unit circle, okay? So print that out, and you can take notes on it for any type of use that you would like to use. Okay, let's say I'm looking at the sine of theta, and I'm talking about 3/5. So I have this triangle right here, 3 and 5, and I can use Pythagorean theorem or realize that this is a triple to know that it's going to be 4. So if I want to talk about 1 over the sine of theta, which would be cosecant of theta, would be 1 over 3/5. You can also see that cosecant of theta would be hypotenuse over opposite. So you can see that these two terms here, 1 over 3/5, is mathematically equivalent to 5/3. Now let's say I'm talking about the inverse sine of 3/5. I would not get out a ratio, but instead I'm going to get out what theta is. I go to my calculator. Let's say right now we're functioning in degrees because that's what my calculator is in. I'm going to go 3 divided by 5, shift, sine inverse, 36.87-ish equals theta. Okay. So inverse function versus the actual function. Watch out for those.